Welcome to the Lensr demo video. In this video, I'll give you a quick overview of how to use our app and demonstrate some of its key features. For a more detailed tutorial, please visit our project wiki on GitHub. After opening Lensr, you'll notice 6 menus on the top of the screen. I'll go through all 6, starting with probably the most important one, light sources. There are 4 types of light sources in Lensr: ray source, beam source, full point source, and lastly, partial point source. They all have 2 user-controlled parameters: array wavelength, expressed in nanometers, and brightness. The latter 3 light sources also have a ray count parameter, controlling how many rays a particular light source emits. Additionally, the partial point source has a field of view parameter, controlling its emission angle. Next up, mirrors. There are 4 types of mirrors in Lensr: line mirror, arc mirror, ellipse mirror, and funny mirror. They reflect the incoming light. They have a single controllable parameter, reflectivity. It controls the percentage of ray brightness preserved after reflecting, where 1 means perfect reflection. One mirror type that stands out is undoubtedly the funny mirror. Instead of placing a shaped mirror, you can freely draw your own mirror that will convincingly interact with the light on the scene. Next, glass. There are only 2 types of glass objects in Lensr: the spherical lens and prism. They both have 2 controllable parameters, Cauchy coefficient A and B. Glass objects use Cauchy equation to find the refractive index of an object for a given wavelength. This allows the user to accurately simulate light dispersion. And the last object menu, Miscellaneous Objects. It includes the light ether, Gaussian roll-off filter, brick wall filter, and the light sensor. Light ether, as the name implies, consumes all incoming light. Gaussian roll-off filter models the transmission rate of a passband filter. You can set its passband, transmission at peak, and full width at half maximum. The brick wall filter represents a filter object that acts as a wall made of bricks for specific wavelengths of light. You can set the start and end of its transmission line, as well as its transmission rate. And the last object in this video, the light sensor. It collects the total brightness per wavelength of every ray that passed through it. It's worth noting that the filters and the light sensor use a custom-made interactive graph to display the relevant object data. For example, the light sensor plots the total brightness for each wavelength that passed through it, and the filters display their transmission rate per wavelength. The last 2 menus are for editing actions, like deleting or duplicating an object, exporting the current scene to a .lensr file, or undoing the last action, and much more. Again, for a more detailed breakdown of all elements of our app, I recommend checking out the project wiki on our GitHub. Thank you for watching, and happy simulating!